With the June SAT right around the corner, a lot of my students are asking me, what's going to be on the test? So in this video, I'm going to summon my powers of divination and gaze into the future! We're not doing that? Look, y'all. No one can gaze into the future, but anybody can gaze into the past and use that to make informed guesses about the future. And that's exactly what I've done here. I've gathered leaked copies of a bunch of recent administrations of the digital SAT, and I've scoured them carefully in search of trends. And I've used those insights to make 10 predictions about what I think is likely to appear on the upcoming version of the test. So whether you're aiming for a perfect 1600 or simply want to improve your score, stick around for an inside look at what you can expect to see on test day. Prediction number 1. The vertex form of quadratic equations. Several questions on recent administrations of the digital SAT have required students to construct the vertex form of quadratic equations.
Mr. Greenberg! Mr. Greenberg!
Hello there, student me.
What is the vertex form of a quadratic equation?
The vertex form of a quadratic equation f of x is a times x minus h squared plus k, where hk represents the vertex of the parabola, and a is a constant that determines the parabola's width. Now that we've gotten that out of the way, let's check out a question from a recent exam to see how the vertex form might be applied. We'll begin by reading the question. The quadratic function g models the depth in meters below the surface of the water of a seal t minutes after the seal entered the water during a dive. The function estimates that the seal reached its maximum depth of 302.4 meters 6 minutes after it entered the water, and then reached the surface of the water 12 minutes after it entered the water. Based on the function, what was the estimated depth to the nearest meter of the seal 10 minutes after it entered the water? Now it's pretty clear that to answer a question like this, we're going to need to construct an equation to model the seal's depth as a function of time. And they've given us the vertex. It says that the seal reached a maximum depth of 302.4 meters 6 minutes after it entered the water. So the vertex is going to be 302.4. Now that we've established that, we can construct an equation using the vertex form. And when we do that, we get g of t equals a times t minus 6 squared plus 302.4. Now there's still a little work that needs to be done because we don't know the value of a. However, it's important to realize that they've also given us another point. The question tells us that the seal surfaces after 12 minutes, which means that at 12 minutes, its depth is 0. If we plug that point into our equation, we get 0 equals a times 12 minus 6 squared plus 302.4. And that simplifies to 36a plus 302.4. Now we just subtract 302.4 from both sides and divide by 36 to solve for a. And when we do that, we can see that a equals negative 8.4. Now that we've solved for a, we're ready to return to our equation. The question is asking us to determine the depth of the seal after 10 minutes, so we plug in 10 for t. And when we do that, we get g of t equals minus 8.4 times 10 minus 6 squared plus 302.4. Of course, we could just solve that by hand, but it's much faster and easier to plug it into Desmos or another calculator. And if we do that, we'll see that the seal's depth at 10 minutes is 168 meters. Prediction number 2. Punctuation that influences meaning. Normally, punctuation questions are just about, well, punctuation. Like if you have two independent clauses, you'll want to separate them with a period or a semicolon, but not a comma. However, lately, we've been seeing some punctuation questions where the punctuation influences meaning. And most of these questions involve the placement of punctuation relative to key transitional words or phrases. Let me show you an example from a recent test to demonstrate what I'm talking about. We'll begin by reading the text. And because the words are the same in every answer choice, we can read it with the words plugged in. It will make a lot more sense that way. Recent analysis of 2010 BL4. an outer solar system object orbiting the Sun between Jupiter and Neptune, has determined its color to be gray, suggesting an icy composition. Such interpretations are ultimately speculative. However, the object's gray coloration may be an incidental effect of radiation, solar wind, or collisions with other objects rather than evidence of its physical makeup. Now, looking at the sentence with the blank in it, we can see that it's actually two complete sentences. Such interpretations are ultimately speculative is a complete sentence, and from the object's gray coloration all the way up until the end of the text is another complete sentence. And because complete sentences can't be separated by commas, most students can easily rule out answer choices A and B. But what about C and D? Both answer choices separate the complete sentences with a semicolon, which is grammatically correct. The only difference is the placement of the transitional word, however. Does it belong in the first half of the second sentence, before the semicolon, or in the second half of the second sentence, after the semicolon? To determine that, we'll need to consider meaning. The transition, however, is used to indicate contrast between the clause that it modifies and the previous clause. If you put it after the semicolon, like in answer C, it suggests contrast between the first and second halves of the second sentence. But the first half of the second sentence tells us that our interpretations are merely speculative. In other words, we don't really know for sure. And the second half of the second sentence builds on that idea by providing some alternative explanations. So it wouldn't make sense to have a contrast transition between them. So what if we put the however before the semicolon, like in answer choice D? That would suggest contrast between the first sentence and the first half of the second sentence. The first sentence tells us that recent analysis of the object 2010 BL4 suggests that it has an icy composition. But the first half of sentence 2 tells us that this is merely speculative, which again means that we don't really know for certain. That is a contrast relationship, which means that the however makes sense. We found our answer, and it's D.
Mr. Greenberg! Mr. Greenberg!
What is it, student me?
Isn't it weird to put however before a semicolon? I'm used to seeing it after a semicolon or a period, like at the beginning of a sentence.
Fair question, student me. However is part of a class of transitions known as conjunctive adverbs, along with words like moreover, nevertheless, therefore, for example, and a bunch of others. Most of the time, these transitions appear at the beginning of a clause, but you can also place them in the middle or even at the end of a clause, and it doesn't impact the meaning. Just remember that wherever one of these words appears within a clause, it represents the relationship between the clause that it modifies and the previous clause. Prediction number 3, constants in equations with no solution. So I'm talking about questions that give you an equation with a variable and a constant, and then ask you to determine the value of the constant such that the equation has no solution. These questions have been coming up a lot on recent tests, especially on the hard version of Module 2. Let me show you an example to give you an idea of what I'm talking about. In the given equation, t is a constant. The equation has no solution. What is the value of t? Now, a question like this may seem hard, but there's a simple trick. And the trick is to make those terms on the left side cancel out. Because if we do that, we'll get an equation that tells us that 0x equals 37. And an equation like that obviously has no solution, because 0 times anything is 0. So to get those terms to cancel out, all we need to do is to set 10tx equal to 3x. And now that we've established that, solving this question is a breeze. The x's cancel out, so all we need to do is divide both sides by 10, which leaves us with t equals 3 over 10. Prediction number 4, punctuation with names and titles. Lately, the SAT has been full of questions that require you to know the rules for punctuating names and titles. Let me show you an example from a recent test. We'll begin by reading it, and because the words are the same in every answer choice, again, we'll read it with the words plugged in. The Austronesian language family includes Samoan, Palauan, and some 1,200 other languages throughout the Pacific, making it one of the largest families in the world, and of keen interest to linguist Sandra Chung of UC Santa Cruz. Now you may be familiar with the rule that non-essential information should be surrounded with commas, and essential information should not. But when is a name considered essential? The answer is actually really simple. In almost every case you'll see on the test, names are essential, which means that the correct answer will be the one with no punctuation, which in this case is answer choice D. Now there is one exception which you should take note of, which is if it says a or an before the position. Like if it said a linguist Sandra Chung, the name Sandra Chung would be considered non-essential, which means that it would need to be surrounded by commas. However, if it just says linguist Sandra Chung, as it does here, or if it says the linguist Sandra Chung, the name is considered essential, which means that you don't want to use any punctuation. Prediction number 5, unit conversions with squared measurements. On the SAT, you'll see a ton of problems that ask you to convert a measurement from one unit to another. These questions are usually pretty easy, but if you're not paying attention, it's easy to get tripped up. And one of the most common ways they'll trick you is by asking you to convert from a length to an area, or a squared measurement. Let's check out an example. A certain park has an area of 11,863,808 square yards. What is the area in square miles of this park?
Mr. Greenberg, that's easy. It says that 1 mile equals 1,760 yards. So just divide it by 1,760.
Oh, student me, you fell for the trap. That conversion ratio was for miles and yards, but the park's area is measured in square miles or square yards. And when you're squaring a unit, you also need to square the conversion rate. So to solve this question, what we actually need to do is to take that area of 11,863,808 square yards and divide it by 1,760 squared. And if we do that, we can see that the answer is actually 3.83, or B. Now before we move on to the next prediction, I'd like to interrupt with a brief public service announcement. We've released a textbook, Digital SAT Reading and Writing The Ultimate Guide. Now I may be a little bit biased, but I'm pretty confident that it's the best resource out there for reading and writing on the Digital SAT. It's got chapters to help you tackle every question type, along with drills targeting specific skills, resources to help you master challenging vocab and grammar, and realistic full-length practice modules to help you put it all together. If you want to pick up a copy, I'll leave a link in the description, along with a promo code that you can use to get 25% off your purchase. Now back to the video. Prediction number 6, verb formation with deceptive main verbs. Most verb formation questions on the Digital SAT are pretty straightforward. However, lately we've been seeing some questions with deceptive main verbs. Verbs that look like they should be main verbs, but really aren't. Let me show you an example of what I'm talking about. On September 18, 2006, American astronomers detected a supernova, the explosion of a massive star, in the constellation Perseus, 240 million light-years from Earth. The powerful blast, blank, from the collapse of the star's core under the force of its own gravity ejected particles at speeds of thousands of miles per second. Now, if you're reading this question quickly and aren't paying attention to the end of the sentence, your ear is going to tell you that you need to supply a main verb. And because it's talking about something that happened in the past, you'll probably pick answer choice D. It sounds right on its own. The powerful blast resulted from the collapse of the star's core under the force of its own gravity. But if you keep reading, you'll notice that we already have a main verb, ejected. And the only possible subject of that verb is the powerful blast. The powerful blast ejected. So whatever comes between them has to be a phrase describing the blast. That means we don't want a main verb in the blank, which means that the answer is going to be the only one that isn't a main verb. B. If you're still confused, let me read the sentence for you with correct emphasis so that you can hear how it works. The powerful blast, resulting from the collapse of the star's core under the force of its own gravity, ejected particles at speeds of thousands of miles per second. So the takeaway here is that when you see verb formation questions, you need to be careful. Always read until the end of the sentence. Prediction number 7. Equation systems with no solution. So before we talked about equations with no solution. Now we're going to talk about entire systems of equations with no solution. These questions have also come up a lot on recent tests, and although they may look more complicated, with the right approach they're actually really easy. Let me show you an example to give you an indication of what I'm talking about. One of the equations in a system of 2 linear equations is given, where n is a positive constant. The system has no solution. Which equation could be the second equation in the system? Now the key thing to remember is that if a system of equations has no solution, the equations must be distinct, but have the same slope. And that can be hard to calculate, but it's really easy to determine visually if you just graph them. So let's head on over to Desmos. I'm going to start by typing in that original equation. 31 times x minus n equals 31y plus 31n. As you can see, it's given me a slider for n. But since the question says that n can be any positive constant, we should be able to leave it at the default value, 1. Next, I'm going to plug in the answer choices one by one, starting with A. 3x minus 3y equals 6n. As you can see, this equation is indeed parallel to the first equation, but it's not distinct. It's the same equation, which means it has infinitely many solutions. So we can cross it off and move on to B. 3x plus 3y equals 3n. This one is obviously not parallel. It intersects the original equation at one point, which means that it has one solution, not 0. So we can cross it off and move on to C. 3x plus 3y equals 6n. Again, we can see that this one is clearly not parallel to the original equation. It intersects the original equation at one point, so we can cross it off too. Now at this point, we know from process of elimination that the correct answer must be answer choice D. But let's confirm that by graphing it. 3x minus 3y equals 3n. As we can clearly see, answer D is indeed parallel to the original equation, confirming that it's the correct answer. Prediction number 8. Dangling modifiers. Every administration of the digital SAT from the past year has had at least one dangling modifier question. These questions are easy to identify because they almost always begin with a modifying phrase, followed by a comma and a blank. Let's check out an example. Now with a question like this, all we need to do is to look at the last sentence, and specifically the first part of it. A theoretical relationship between tax rates and revenues, blank. So the key thing to remember here is that whenever you start a sentence with a phrase followed by a comma, whoever or whatever the phrase describes must come immediately after the comma. Therefore, the question we need to ask ourselves is, who or what does this phrase describe? If it's not obvious, we can check the answers one by one, paying special attention to what comes first in each, and seeing if it makes sense. Let's try that right now. Answer choice A starts with Arthur Laffer. Could Arthur Laffer be a theoretical relationship? Of course not, he's a person, so we can cross off A. Answer choice B starts with economist Arthur Laffer. Could economist Arthur Laffer be a theoretical relationship? Again, obviously not, so we can also cross off B. Answer choice C starts with the curve. Could the curve be a theoretical relationship? Maybe. After all, a curve expresses the relationship between two variables. But if we're still not confident, let's check out answer choice D. That one starts with a napkin. And there's no way that a napkin could be a theoretical relationship. So the answer has to be C. A question like this is really easy when you know what to focus on. The problem is that if you're not used to it, you may get distracted by things that don't really matter. So remember this pattern because you will almost certainly see it on test day. Prediction number 9, standard deviation. Standard deviation questions appear on almost every administration of the test, and they're really easy to solve if you know how to approach them. But if you don't, they can be huge time wasters. The important thing to know is that in most cases, you can solve them quickly in Desmos without having to do any calculations yourself. In fact, you don't even really need to understand the concept of standard deviation. Let me show you an example. Data sets A and B each consist of 6 values as shown, where h is a constant. If the standard deviation of dataset A is greater than the standard deviation of dataset B, which of the following could be the value of h? So as I was saying before, you could try solving a question like this manually, but the far easier approach is just to use Desmos. In Desmos, if you want to calculate the standard deviation of a set of numbers, all you need to do is type in stdev and then type in the numbers in parentheses separated by commas. Let's do that right now for the first set to figure out what its standard deviation is. So I'm going to type in stdev parenthesis 8, 11, 12, 15, 21, 27, and then I'm going to close the parentheses. And as we can see, the standard deviation for that first set is 7.08989. Now we're going to do the same thing for the second one, data set B. stdev parenthesis 9, 12, 13, 16, 22, h, and then close the parentheses. Now because we've put in a variable h, as you can see it's given us a slider. But all I need to do is to set that slider to the different possible answer choices. So the first possibility they gave us is 23. Let's set the value of h equal to 23. And if we do that, we can see that the answer, or the standard deviation of the set, is 5.6361. And that is clearly lower than the standard deviation of set A, which means that it satisfies the criteria. Next, we'll move that slider up to the second value that they gave us, 28. And when we do that, the standard deviation of set B is 7.0898989, which was the same as the standard deviation of the first set. So it doesn't satisfy the criteria. Finally, we're going to go ahead and do the same thing for that last option, 29. And when we put that in as the value of h, we can see that the standard deviation becomes 7.4139, which is greater than the standard deviation of the first set. So that also doesn't satisfy the criteria, which means that the correct answer is going to be only option 1, which is A. Prediction number 10, rhetorical synthesis, where the research notes matter. So for those of you who aren't familiar with the terminology used by the College Board, rhetorical synthesis questions are the ones that give you a bunch of notes taken by a hypothetical student, and they ask you to use the information from the notes to achieve a particular goal. And with these questions, the best approach is usually just to ignore the notes completely, because you don't need them. Usually, there's only going to be one answer choice that satisfies the goal. However, on recent administrations of the digital SAT, we've seen a few questions where the research notes actually do matter. Let me show you an example. I'll start by reading the question. The student wants to explain an advantage of the oak tree house dwelling site. Which choice most effectively uses relevant information from the notes to accomplish the goal? Now we can try to solve this question using our standard approach, which is to ignore the research notes entirely and focus on the goal, which in this case is to explain an advantage of the oak tree house dwelling site. Answer A tells us that the location of the oak tree house provided an advantage, but it doesn't explain that advantage, so it can easily be ruled out. Answer B doesn't even mention an advantage of the location, so it can be ruled out too. But both C and D satisfy the goal. C tells us how the location allowed for the construction of large terraced buildings, while D tells us that it offered protection from the rain and snow. Both of those are advantages. That means that we need to take one more step and look at the notes. If we do that, we can see that the flat terrain allowing for the construction of large terrace buildings was not a feature of the location of Oak Tree House. It was actually a feature of Yucca House. Therefore, it's factually incorrect and can be eliminated, which means that the correct answer must be D. Questions like this are still relatively rare on the SAT, so I'm not confident that you're going to see this one on test day. But I wanted to include this prediction just to make it clear that it could. So remember, if you see a rhetorical synthesis question where more than one answer choice satisfies the goal, you'll need to look carefully at the notes. So there you have it. 10 predictions to help you maximize your score on the upcoming SAT. I hope you found this video helpful. If you did, don't forget to like, comment, and subscribe. Thanks as always for watching, and good luck on the test.